Is any students joining the class? Wait another 2-3 minutes and check whether the students are coming or not. Or else we'll solve remaining two problems and we'll stop the class. Okay. So coming to the remaining problems, that is on finding present worth factor or the present value of the money or whatever the best possible saving ideas are there that we are going to validate. So I hope screen is shared here. Yes, present. Okay, we'll complete this part and in the next class we'll take payback period. Yeah, last class we discussed on this insulation system of a house and we got that depending upon the other alternatives, this alternative was better at the cost of savings. You can see after the number of years, okay, 15 years, the savings were 57,800 rupees based on energy or heating and cooling of the building. Now today we'll take one simple economics problem, not related to any solar energy or the fuel like that thing. We'll just observe how this value of the money is going to change depending upon spending or any investment which is going to produce some advantage to the customer. So first case they have given a loan of rupees 80,000 is to be paid to a bank in equal monthly installments over 20 months. So 20 months, for 20 months he is going to take a loan of rupees 80,000 today. Okay. Then in 20 months he has to pay the EMIs, equal monthly installments. Okay, so that EMI, how much he has to pay? So that we have to check here because they are asking find the monthly payments. So for this, what is the rate of interest that the bank is going to ask is 15%. So coming to the present worth factor, again the same equation. So the equation is present worth factor is given by 1 minus 1 divided by 1 plus this rate of interest per month. Because in the question they are asking for the month, so I'll consider this rate of interest as per month. That rate of interest are raised to n. N is the for number of years. So as they are told 20 months. So here I am not going to consider years. If it is years, I would have considered rate of interest for the given year or the number of years and number of years as n. So both I am going to consider in terms of months. Now coming to this problem, in the given question, the bank interest rate, whenever they tell it is for the year. Okay, always bank or any loan provider will give the interest rate for a given years. Okay, so per year it is 15%. So according to that 15% for given number of months, if I consider, so I have to divide it by 12 months in a year. So 15 by 12 if I consider, then I will get this rate of interest per month and I can substitute in the above equation where all the values are considered as per month. So I'll take this 15 by 12, that is 1.25% per month, and I'll substitute in this above equation. Then rate of interest is known for the month and number of months, n value is given in the problem, that is 20 months. So just once you convert these values and substitute, after substitution I have got here 1 minus 1 divided by, see here 1 plus rate of interest per month raised to n into 1 by r. If you take all these values and substitute, so you will get one factor and that factor into amount you have to do, or per month if you want to find out you have to divide it. So monthly loan payment if I find out for the total amount, Okay. Earlier problem what we did, per month what is the investment we found out, and that investment we have multiplied with the factor in the earlier problem. But here it is not an investment, it is a borrowing of money or taking the loan. So once you take the loan amount is huge. So per month how much we need to pay? So to find that, we are going to divide this value 17.6 factor, present worth factor. So per month, that person who has taken the loan of 80,000, he has to pay for 15% and 20 years of, 20 months of installments. He has to pay every month 4,545.5 rupees. Every month he has to pay this amount until 20 months is over. So if you multiply this equal monthly installments or EMI of 4,545.5 into 20 times, you will get the total amount for 15%, how much he is going to pay. If you want the total amount to be paid, that is different. But in the question, they have asked only find the monthly payment. So that we have found out. Similarly, we'll go to the one more case. If the borrower could have invested same amount, rupees 80,000 at the interest rate of 12%. Now see, now borrower what he is doing, say for example, he has taken 80,000 loan, whatever it is, or after the with paying of that loan only in equal installments. Also that loan amount, if he keeps, if the same loan amount taken in the first case, if he keeps as an investment with a rate of interest 12%, okay, 12% per year, then what is the present value of rupees 80,000? So these two cases, they are not combined, so we are not taking any difference of amount or whatever. We are taking this as a fresh problem. So 80,000 he has invested and he is going to earn. See the difference here. He is going to earn here 12%. So 12% means per year. So now what we have to find out, what is the present value of rupees 80,000? So this we have to find out. So similarly, if you want to find out for monthly rate, you can go for monthly, because with the second problem also we are taking 20 months only. So 20 months, what is the advantage? Or in this solar energy subject, we can assume this same problem. He is going to invest 80,000 in solar energy plant, and every year he is going to save the fuel cost of 12%. I hope you are getting. It is indirectly what they are telling in the general economics. They are telling 80,000 is invested and monthly advantage is how much, or rate of interest is how much. He is getting 12%. This we can compare with solar energy also. Solar energy PV system or the thermal system, he is getting 12% in returns. Means he is going to save that much of amount of fuel or whatever it is. So for 20 months, if you want to find out, I'll convert this 12% per year to per month. So per month, if you want to find out, again what I'll do, I'll divide this value by 12. So what's the value of interest? 12 divided by 12. It is 1%. So 1% I will write it in numbers. That is 0.01 per month. So I'll substitute on the same equation, that is present work factor is given by 1 minus 1 divided by 1 plus r raised to n. N is the number of months. Okay. So in the problem, if they give years, you keep in years only, don't convert it. In the problem, if they are asking for months or any values are given in months, keep this rate of return or rate of interest and number of months all in months only into 1 by r, that is 0.01. So once I substitute and find the values, the factor is 18.04. Okay, 18.04. Now to find out the present capital cost of the 80,000 rupees over 20 months of advantage. Okay, over 20 months he is going to get each month 1% return or per year 12% return. So on that basis, how much amount he is going to earn in this second case. So for that, this factor is multiplied with monthly earning. Is that clear? Or monthly spending if you take. So monthly spending for 80,000 were 4,545.5, and if he earns some factor 18.04, okay, in that case, if I multiply this 4545.4 into 18.04 with combination, okay, with combination, if I do it, I will get 82,000 rupees. Means the benefit on investment is more compared to the taking the loan from the person. Others, what he can do is he can take the loan, he can invest in such a application where rate of return or with respect to the monthly EMIs, he can overcome that monthly installments and he can earn his own money. So finally, the present worth of the capital, if you want to find out, that is nothing but the spending or the earning of this person. If you see 80,000 rupees, if you keep for 20 months and at a rate of 12%, or 80,000 rupees, okay, 80,000 rupees per month, whatever EMI he was paying there, with this factor, if I multiply, then I may get the present worth factor of this money. The present worth of 80,000 as per the given conditions above, it will be 82,000 rupees. Here also to understand in more detail, with discounting is also given. Cost of a solar heating system only for the maintenance cost in total lifetime is, you can see the amount there, rupees 800 into 10 raised to 3, 8 lakh rupees he has to spend only for the maintenance of solar heating system. And the present value of maintenance cost, if the first year cost is rupees 40 into 10 raised to 3. See, here again they are asking the present worth. What may be the present value of this maintenance cost if first year maintenance cost is 40,000? Okay, they are now in 10 raised to 3, we'll write it as it is. 40 into 10 raised to 3 rupees. And inflation rate is 10%. So this inflation rate you can consider for the fuel, what alternate fuel or the conventional fuel he was using. So on that, inflation rate was 10%. It was increasing. The best alternative investment rate available is 12%. So if the same amount, if he keeps for a investment, he can earn 12%. The life of the system is 12% or 12 years. So for total 12 years, he has to spend 8 lakh rupees for the maintenance. And first year, he is going to pay 40,000 rupees for the maintenance with inflation rate 10% and discount rate is, sorry, alternative investment is where he is going to earn. Okay, so that earning, we are going to call it as discounting. Here also we have done same thing. 80,000 loan is taken. That 80,000 he is going to invest, because for investment only we are taking loan. So where we are going to invest, so depending upon that benefit from the investment, we are going to find the present worth. Okay, so similarly here what they have done is they have taken inflation rate into consideration 10% of the present worth, and here discounting is also given. So as per the discounting and inflation equation is taken there, and number of years they have given 12 years. So no need to convert this percentage into months with this problem. Okay, that is the difference. So present worth factor, if you want to find out for these given conditions with inflation, discounting, and in number of years. So equation will be 1 minus into bracket 1 plus I by 1 plus d whole raised to n bracket close into 1 by d minus I, which is the regular formula for present worth factor. If it is only rate of interest without any discount or inflation was given, we can go by this equation, 1 minus 1 by 1 plus r raised to n whole bracket into 1 by r. After substituting, you can see present worth factor is coming around 9.7, and if you multiply, I can find out present worth value or present value. So present value for the years altogether, if I find out, okay, so 40,000 he is spending first year. So into 9.7, if I multiply, the present worth is how much? It is around 3 88 into 10 raised to 5. Okay, so that is the maintenance charge because discounting is given here. With discounting, you can reduce that 40,000 to somewhere around, you can check the values, how much will be the value. So that present value of the maintenance charge we want to find out. Okay, it is around 3,88,000. So 3,88,000, it is going to reduce some initial investment in the maintenance itself because of the discounting, or you can say whatever the fuel inflation was there. According to the fuel inflation, some discount is happening in the solar system because it is not taking any inflation here. So that two values we are going to compare and we are checking with discount how much it is going to reduce. Okay. So in this problem you can see, we'll take this problem and we'll stop the class here. Yes. Last problem on the present work factor. Calculate the cost of fuel. Just a minute, yes. Calculate the cost of fuel of a conventional non-solar energy, because to tell the customer, they are telling it as non-solar. Non-solar in the sense it is a non-renewable energy source. From the non-renewable or conventional energy source, the fuel cost we need to calculate. Calculate the fuel cost from the of a conventional system for 15 years. So for 15 years, what is the fuel cost by conventional system like petrol, diesel, or coal, that we need to find out. If the total annual load is 114.9 gigajoules. Giga means 10 raised to 9. 114.9 into 10 raised to 9 joules is the annual load, total annual load. And the fuel rate is $7.2 per gigajoules. So here you can, for easy understanding, we can assume rupees also. In place of dollars, I will assume rupees. So I'll say rupees 17.2 per gigajoules. Per gigajoules power to produce, the fuel rate or the fuel price is 17.2 rupees. The market discount rate is 7% and the fuel inflation is 4% per year. Now this entire problem you can see it is not connected with any solar energy. Okay, it is just directly based on the conventional energy system. So in this, if by chance because of the gigajoules power production, some discount may be available from the government to the fuel, and inflation rate, no one can stop that. So inflation rate will be there every year. The fuel prices are going to increase, so that is called as inflation rate. So that is 4% per year. So because of this inflation and large quantity of energy requirement, they are getting discount of 7%, more than inflation they are getting. So finally, what we need to find out here is we need to calculate the cost of fuel for 15 years. So for 15 years, what will be the cost of fuel? And also, if required, I can go for the present work factor. That only will give us total amount required, because each year, if you find out, the process will be very hectic. That also we can do. In this process, we can do each year how much will be the fuel cost and the present work factor we can find out by making such table. But to reduce the time, this formula can be used. The cost of fuel, if you see the first year cost of fuel, so that can be found out by using the fuel rate per gigajoules. So per gigajoules, what is the fuel rate? It is 17.2 rupees as per our assumption, or $17.2 into total load. Total load is 114.9 because per gigajoules is 17.2. Then for 114.9, 114.9 gigajoules, what will be the cost? So for the first year, it is coming around $1,976.30. Okay, or this dollar only can compare change as per the today's rupees value. Okay, so 1976.30 rupees or $30 is the cost of fuel required first year. Okay, now after 15 years, what will be the cost? So to find that, either you can go by conventional method or by this formula method. What they are doing is using this present worth factor formula. So after 15 years, what will be the total cost? That can be found out using the factor. So here in the question, discount is given, inflation is given. So same formula we take, and also months are not given, years are given. So I'll take the formula, that is 1 minus into bracket 1 plus I divided by 1 plus d raised to n into 1 divided by d minus I. Same formula, just they have swapped the parameters. So now you substitute. Discounting is 7%, so it is 0.07. Inflation is 4%, it is 0.04. And number of years is 15 years. So present worth factor is around 11.5752. So by that rate, the present cost or the first year cost of the fuel is going to increase. So present worth of the fuel cost means in the future for 15 years, what may be the value of amount required. So 1976.3 dollars into factor, that is 11.5752. That will give us the present worth of the fuel cost or the present value of the fuel. So that is coming around $22,876. Okay, so this can be seen with a much quicker method because of the formulas. But you can see in the other method, what they have done is this first year fuel cost they have taken 1976.3 fuel cost. First case you can see here 1976.30. With the same fuel cost, they are going to multiply with the inflation rate. Okay, inflation rate is how much? 4%, and discount given is 7%. So effectively, if you find out for the next year, that is coming around 2055.35. You can use a calculator and you can check what is the fuel cost with the same rate of inflation for the next year. So 1976.3 into inflation 0.04. So factory difference is coming around 79 plus 1976.3. So with inflation rate, the fuel costs are increased by second year, that is 2055.35. I am also getting same answer. So similarly, you take again 2055.35, again multiply with the next inflation rate and get this answer. So like this you do for 15 years. Okay, so like this if you go by 15 years, then you can find out what is the total cost of fuel required for 15 years only with inflation. But other than inflation, if you consider some discounting, okay, with discounting if you find out, you can use this formula and you can find out all these present worth of fuel for first year. Because see here, without discounting the fuel price was 1976.30, but with discounting we don't know. So with discounting if you find out, discounting is how much? 0.07. Okay, 7% they have given. So that if you find out, the value will be different. Okay, so with discounting if you total it, the value of the fuel cost will be 22,876. But without discounting, if you see, it will be very high. So like this also you can make a table, but for each year you need to find out. So to overcome this difficulty, you can go by directly formula. So directly they are asking after 15 years what is the condition with the discounting. So that is around $22,876. Okay. Yes, one more column is left out. So we'll take this problem and stop the class. So this is again on the present work factor, though that's why we will complete this in the same class. So in this problem, we need to again calculate the present worth of a fuel cost over 10 years. For fuel cost is 10 euros. So in this problem, it is euros they have given. For simplicity, we'll assume rupees only. Okay, like rupees 1400 first year we have to pay. And inflates, this fuel inflates at 8% for 4 years and 6% for the rest of the years. So in this problem, what we need to understand is out of 10 years, inflation rate is changing here. Okay, in the first year, the fuel cost is 1400. After that 4 years, how much is the inflation rate? 8%. So total it becomes 5 years and 6% for the rest of the years. So out of 10 years, if you take out of 10 years, first year is 1400. Another 4 years, if you take, it is 8%. Then left out years is 5 years. So in last 5 years, it will be 6% inflation rate. The market discount rate is maintained same, 7% per year. So taking all these values and substituting in the directly the present work factor, one can find out with the different inflation rates and different years, what will be the present work factor or the present work value. Okay, so here you can note down the problem. In that they have given first settlement of money with 1400, and after that 4 years inflation rate will be 8%. So the first plus 4, according to the problem definition, they have considered 1400 into this factor. So for considering 5 years in the equation, they have taken 1 divided by 0.07 is the discounting, minus inflation is 0.08 into bracket 1 minus 1 plus I. So that 1 plus I will become 1 plus 0.08. 1 plus 0.08, that I can write it as 1.08 directly, divided by 1.07 whole raised to 5 for 5 years. So that factor is coming around 4.7611. So if I multiply this with the fuel expenditure from first year, that will coming around 665.54 euros. Okay, so this is for the first inflation rate for 4 plus 1 year, 665.54 euros. Then second set is what? 10 minus 5 if I take again 5 years. Okay, again 5 years they have considered. So second set starts at the beginning of the 6th year, 6, 7, 8, 9 and 10, 5 years, 6th year. And for this period, inflation rate is 6%. So to find the initial payment for this set, that is euros 1400 is inflated 4 times by 8% and 1 time by 6%. Because we need to find out in the earlier stage for 4 years, first payment was known here, that is 1400. But after 5th year, what is the amount what we are going to continue with inflation of the fuel? That we don't know. So to find that, what they are doing is 1400 and 4 times of inflation, that they have taken 1.08 value for 4 years, and another year, because to start with the 6th year, this 0.06 inflation rate should be multiplied, and to take that 1 plus I and 1 plus D, they have taken 1.08 and 1.06. So this whole term, what it will do is, why they are calculating is, at 6th year, okay, to start with the 6th year, the fuel payment or the fuel cost at the 6th year is this much, 2018.97 euros. So how they are finding? 1400 initially. Okay, after this, next 4 years, what they did, They have paid with 1.08 raised to 4 inflation rate, 4 times. And sixth year to start with, the inflation rate was 6%. So 1 plus I if you take here 1 plus I if you consider, that is 1 plus, sorry, 1.06. All these terms if you multiply, you can get this value. Or else what you can do is separately you can find out 1400 plus. Okay, plus. Next, second year, what is the payment with inflation rate? As I told in the table how they did here. Same thing you can do here also. Okay, first year, second, third, fourth, fifth. After fifth year, you take this inflation rate and take the value of that amount. Then at the sixth year, I will get 2018.97 with discounting as well as inflation. Now this amount they are going to use for the next 5 years. Is that clear? So this amount they are going to spend as a sixth year, and from sixth year, what is the inflation? 6%. Only that is a change. Discount will remain same. So change is what? Number of years is same. Inflation rate is changing. Discount rate is again 0.07. So keeping that in mind, I will get the present work factor for the next 5 years. That is 4.5864. Okay. So taking all these values, second set of payments need to be discounted to the present work by what they're doing now, 4.5864 into initial cost of fuel, what is required at sixth year, 2018.97. Okay, so this will give you present work value for fifth year, for 5 years, next 5 years. This is the value. Okay, this is the value, and discounting is again 7%. If you see the discounting, so with discounting, what they have done, they have divided this by 1.07 raised to 5. So that will give around how much euros? 6602.11. Okay, 5 years we are finding with inflation rate of 6%. Before that, we have found out the inflation rate for 8%. 8% for 5 years. So both together, if you add, that will give you total present sum of fuel spending. So cost of the fuel at present, what is required for next 10 years. Is that clear? Here the inflation rate is split up. So similarly, discounting is also split up. But discounting rate remains same. They have not changed it, but the inflation rate is going to change. So as per the change of inflation rate for the different years, they have found out the present worth factor. And afterwards, you need to add these two 5 years different inflation rates. So those rates will be 6,665.54 for first 5 years. Next 5 years present worth is 6,602.11. So totally we are getting 13,267.65. Okay, at this point we'll stop the class. Next class we'll continue with the payback period. It's the last part of solar economics. So if any doubts are there until here, you can come up with the doubts in the next class.
Real estate.